Final quadrilateral that we're going to be looking at is going to be the square. And the square is probably the one that's most familiar to you because it's one of the first shapes that you've ever learned about. Although the square seems to be the simplest of all quadrilateral, it has more properties than all of the rest. A square is any quadrilateral with 4 right angles and 4 sides of equal length. There is a picture to the right of that definition. But as we take a look here momentarily, true or false? A square is a rectangle. Well, a rectangle has 4 right angles, so that's one good thing. A rectangle has 2 pairs of parallel sides, so does the square. A square is a rectangle. Not vice versa, because the square has 4 congruent sides, but a rectangle doesn't have to have 4 congruent sides. A square is a rhombus. Well, the thing about the square is rhombus is that a square does have 4 congruent sides, but a square must have 4 congruent angles, 4 right angles, and a rhombus does not. So, I'm going to go false on that one. A square if, I didn't even see that, a square is a parallelogram, and that's true. Parallelogram, definition, 2 pairs of parallel sides. And then a square is a trapezoid. Well, the definition of trapezoid is that we have to have at least 1 pair of parallel sides, and we do. So I'm going to go true on that one also. So, again, the hardest part about the square, conceivably, is that all of the properties of a parallelogram and it has all the properties of a rectangle. And finally, it also has all the properties of a rhombus. So when we're determining if a quadrilateral is a square, what has to happen is we have to start with showing that it's a parallelogram. And then once we show that it's a parallelogram, then we have to show that it's a rectangle. And then after we show those 2 things, then we have to finish by showing that it's a rhombus. So all 3 of those. So if we look at quadrilateral ABCD, it's graphed below, and thank goodness it's graphed for me, so maybe my triangles won't be so wacky. But it says determine if ABCD is a parallelogram by showing that the diagonals bisect each other. And again, when we're showing that the diagonals bisect each other, we have to do the midpoint. And we had that practice in the last note, so hopefully we remember that. And the nice thing is, when we're taking some sort of assessment, at least it gives you some guidance. Show that it's a parallelogram by showing that the diagonals bisect each other. So we're going to start with diagonal AC. And again, I'm going to do the midpoint of AC. We're going to draw our triangle. And it doesn't matter. I'm going to start with C. So we're going to go up and over here to draw that. And what we did is we went up 2. And then I went left. I'm going to have to count. So we went up 2, 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. we went left 14. So when we're finding the midpoint here, instead of going up 2, we're going to go up 1, half of 2. Instead of going left 14, we're going to go left 7. So I'm going to start at C, because that's where I started before. I'm going to go up 1, and then 1, 2, 3, 4, 5, 6, 7. So it looks like our midpoint here is 3, 1.
Aren't you recording?
So we have to find the midpoint of BD. When we find the midpoint of BD, here if I can get the picture drawn, and what we did is we're going to go up a bunch, and then we're going to go over. So if we count here, we went up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We went up 14, and then we went right 2. But we're finding the midpoint. And we're going halfway between here. So up 14 means we're going to go up 7. Right 2 means we're going to go right 1. So if we count from D, 1, 2, 3, 4, 5, 6, 7, and then right 1, we should end up at 3, 1 again. Notice, in case you missed it, that our origin is right here where I put that red plus. So I counted 1, 2, 3 spaces to the right and 1 up. And luckily on this one, at least, we don't have to explain why. We're showing that. And then we're going to go to part B here. So the same picture, but now we have to figure out if ABCD is a rectangle. And again, the nice part is that it gives us directions on it. It says, show that all 4 are right angles. And the way that we show that all 4 are right angles is that we use the slope, and we want to show opposite reciprocals. So once again, as we draw our picture here, I'll start with the slope of AB. So here's our triangle. And our slope, rise, 1, 2, 3, 4, 5, 6. And we run right 1, 2, 3, 4, 5, 6, 7, 8. Use Desmos, use your graphing calculator to simplify that fraction if you have to. That becomes 3/4. Because now what we're looking at is when we do the slope of BC, drawing our triangle here, we want this slope to be the opposite reciprocal. So we want the fraction flipped, and we want a different sign. And as we count from C here, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. We went up 8, but we're going to go left 1, 2, 3, 4, 5, 6. And actually, it's nice that it worked out because even the original slope still had the fraction flipped and it had the sign changed. If we simplify this, this is 4 over -3, and those two values are opposite reciprocals, but we can't stop there. And in terms of space, like I needed to write underneath my graph to finish in the other 2 slopes, so you may have to do that as well. But we now need to find the slope of CD. slope of CD. And when we count, we're going down. 1, 2, 3, 4, 5, 6. We went down 6. And we're going to go left. 1, 2, 3, 4, 5, 6, 7, 8. Negative divided by negative is positive, and if we simplify that fraction with decimals or a calculator, we end up with 3/4. And then when we finish over here with our last slope of AB, drawing in a triangle, we went down 1, 2, 3, 4, 5, 6, 7, 8. We went down 8. And then we went right 1, 2, 3, 4, 5, 6. When we simplify that, we get negative 4/3. And again, opposite reciprocals. The fraction flips, and one of them changes signs. One of them is positive, the other one is negative. And that shows that we have 4 right angles in here. Again, this is all of the process that we have to do to show that something's a square. Because now when we go to the next one here, same picture, and your picture's probably jumbled up, but it says determine if ABCD is a rhombus by showing that the 4 sides are congruent. So the nice part is that we kind of have these labeled already, and I don't have them labeled on mine, but we kind of have them labeled here in terms of our triangles, so that should help you at least on your picture. But where we started here on that last problem is we did AB. So when we're doing the distance of AB, we're going to be using the Pythagorean theorem. So again, we had 1, 2, 3, 4, 5, 6. So it's going to be 6 squared plus 1, 2, 3, 4, 5, 6, 7, 8 plus 8 squared equals C squared. So it should be familiar numbers from our previous part. So we get 36 plus 64 equals C squared. And 36 plus 64 is 100 equals C squared. And when we take the square root of both sides, because we can, we get C equals 10. So our first distance is 10. But as we work through these here, we should find that we're going to be getting the same values. If we do BC, we have the 1, 2, 3, 4, 5, 6, and the 1, 2, 3, 4, 5, 6, 7, 8. We've got the same thing. We've got the distance of BC, and it's 6 squared plus 8 squared equals C squared. We've already done the math. So right underneath, I'm just going to write C equals 10. I've got the math there right beside it. We don't need to do that again. Let's look at the Pythagorean theorem for CD. So the distance of CD, we're going to find it remarkably familiar. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 6 squared plus 8 squared equals C squared. Again, we've done the math. It's in blue. We get C equals 10. And we need to do one more, at least, computation here, which is going to be the distance. How to spell it right? Distance of AB. But as we count, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 8 squared plus 6 squared equals C squared. Still the same numbers. I know it's a different order from what's in the blue, but ultimately, when we solve that, we're still going to end up with C equals 10. There's a little bit more space there in that. But now that we've done the math, we've shown that the figure is a parallelogram, we've shown that the figure is a rectangle, we've shown that the figure is a rhombus, then it says, I must have missed one here. Don't I have to say, is quadrilateral ABCD a parallelogram? I wonder if it's hidden in here. Is a, yep. So sorry, I missed that here. Is quadrilateral RILAT square? And the answer is yes. ABCD is a square. Because it is parallelogram a rectangle and a rhombus. Again, it'll be nice when we can type that. As we flip our paper over, it's going to be the same kind of process on the back here. But when we're showing that something is a square, we have to show, first of all, that it's a parallelogram. And this time what we're going to do is we're going to determine if WXYZ is a parallelogram by showing that opposite sides are parallel. And if there's, again, anything nice for me, it's because we've already got that drawn in. So let's start with ZW, and we're going to do the slope of ZW. Rise over run. 1, 2, 3. We rise. And we're going right. 1, 2, 3, 4. Its opposite side is going to be over here at XY. So if we draw that in, the slope of XY, well, we went down 3, and we went left 1, 2, 3, 4. And what we see there, even though we have negative 3 divided by negative 4, we could make that positive because 2 negatives make a positive. What we see then is that ZW is parallel to XY. So there's one set of parallel sides. And then we can do the other sides here. Here, for this triangle, so the slope of WX and what we did is we rose 1, 2, 3, and we went left 1, 2, 3, 4. So it's going to be negative 3/4. When we look at the slope of ZY or YZ, whichever way you want to write that, we went down 3, there's the rise, and 1, 2, 3, 4, 4 to the right. And what we just showed as well is that WX is parallel to ZY. So we have opposite sides are parallel. Now that we've shown the parallelogram, then we need to go to the rectangle. So determine if the rectangle is, determine if it's a rectangle by showing that the diagonals are congruent. The nice part on this one is, if we look at the distance of WY, which is where our first diagonal is, all we need to count. We don't even need to do the Pythagorean theorem 1, 2, 3, 4, 5, 6. Because it's a vertical line. And then, when we look at the distance of ZX, well, here's Z and here's X. We've got a horizontal line. 1, 2, 3, 4, 5, 6, 7, 8. Well, I don't know if it's bad news or good news on this one. Determine if this is a rectangle by showing that the diagonals are congruent. Well, the diagonals are not congruent. So if our ultimate goal here is to show that this is a square, this is not gonna be a square. Just for a little bit of extra practice here, is it a rhombus? And it says determine if WXYZ is a rhombus by showing that the diagonals are perpendicular. Well, the nice thing is we have our, darn it, wrong color. We have our diagonal here of WY. The slope of a vertical line. You remember what the slope of a vertical line is? It's undefined. And then the counterpoint here, or the other diagonal, if we look at diagonal ZX, well, it's a horizontal line, and if the slope of a vertical line is undefined, then the slope of a horizontal line is 0, and they are perpendicular. They are opposite reciprocals. 0 is 0 over 1. So if we flip that and change the sign, we still get the undefined. It's weird that those are perpendicular, but it doesn't matter here, because when we go and answer this last question, is quadrilateral WXYZ a square? The answer is no, because it is not a rectangle. We failed one of the tests. But lastly, just a little bit of algebra to finish this one. And it says the quadrilateral shown below is a square. Find the length of QR. Well, one of the features of a square is that we've got 4 congruent sides. So if we look at this, instead of question mark, let's call that X. But if we call this X, then this is X as well. Another feature of a square is we've got a right angle. We've got 4 right angles, as a matter of fact. So when we finish, or when we try to figure out our question mark, which is our X in this case, we can use the Pythagorean theorem. We can say X squared plus X squared equals 13 squared. Keep in mind that this is 1x squared and this is 1x squared. And we end up with 2x squared, 269. Well, we want to figure out what does x equal. So let's divide both sides by 2. and we get x squared equals, but when we divide that by 2, we get 84.5. And then finally, use Desmos, use your graphing calculator, whichever works for you. We're going to take the square root of both sides, and we'll get our value of x. And the square root of 84.5 is 9.2. Looking at this value of 9 to determine what to do to the 1, so it's 9.2.